Solving absolute value equations with the graphing calculator. In earlier lessons, we examined solving absolute value equations by first solving for the absolute value bracket on the left, and then setting up two separate equations for two possible solutions using the alternate universe concept. In this lesson, we'll solve the same equations, but by using the graphing calculator. To do this, we need to be able to do three things. First, we need to solve the equation for 0 on the right side. We can do this using the magic bridge concept developed earlier. Also, we need to be able to put the absolute value equation in our graphing calculator to evaluate, and we'll learn how to do that. And finally, we need to be able to read the graph to pick out the solutions on the x-axis as we would on a number line. Here's the first one we'll look at. For graphing, we need to make this calculator ready by setting the right side equal to 0, which we will do by moving the 12 to the left side of the equal sign, thus the magic bridge concept. This becomes, on the left side, the absolute value of quantity 2x plus 6, then minus 12 equals 0. We go to the y equals view in our graphing calculator and enter the left side of the equation. We need to enter this side of the equation. How do we enter an absolute value into the graphing calculator? Well, we do it by first pressing the second key, then we press the 0 key at the bottom of the keypad with the word catalog above it. We're looking for the ABS, or absolute value operation, which luckily happens to be alphabetically at the top of the catalog. Since the little triangle is already just to the left of ABS, we're exactly where we need to be. Now we press enter. We have just what we need. We have the absolute value operation opening the statement. Now we enter what's inside the absolute value brackets, then close parentheses, 2x plus 6. Now subtract the 7. We graph by hitting the graph key, or zoom, then 6. And this is what it looks like. We count from the y-axis, or the origin, to the left. It looks like one solution is -9. The one on the right looks like 3. So it looks like the solution set is -9 and 3. We can check in our table view by pressing second, then graph to get the table view, and we see that 3 is in fact one of the solutions because it's 3, 0, and we can see if -9 is also a solution. We scroll upward with the up arrow until we get to -9, and we see that -9 is also a solution, proving our answers. Check. Let's try another one. We first solve for 0 by bringing the 2 to the left of the equal sign, where it becomes -2 and leaves 0 on the right side. We press the second key, or the y equals key, and we enter the left side of the equation. We start accessing the absolute value operator by pressing first second, then the 0 key with the catalog above it, then press enter. We complete inside the absolute value notation by entering 2x plus 3 and close the parentheses. Then we complete the left side by adding 6 and subtracting 2. We graph by pressing zoom 6 or graph. Does the absolute value function hit the x-axis anywhere? No, it does not touch anywhere on the x-axis, therefore there is no solution. Let's try another one. For this one, we're going to bring the terms on the right side over to the left. And so we had 2c on the right side became minus 2c on the left, and the minus 10 on the right becomes plus 10 on the left. We go to y equals again. We enter the left side in y1. Again, we can't use anything but x for variables here. Now graph it by pressing graph or zoom 6. And it looks like the equation hits the x-axis about 8. Let's look at the table view by pressing second, then graph for table view. And we scroll down to 8 and see that 8 is the answer, or an answer. We can continue to scroll downward and we see that the function never turns upward. It just y1 keeps on going down. Therefore, there appears to be one solution. C equals 8. Let's look at another one. Stop the video and see if you can solve this one, then restart it to see how you did. Alright, the first thing we can do is move that -6 to the right of the equal sign to get 0 by itself on the left. And on the right that becomes +6, and we have 0 on the left, and we're ready to enter this in the calculator. And we enter the expression on the right side this time. Now remember to get the absolute value operation by pressing second, then 0 for catalog, then enter. Also remember that here you need to use x as the unknown. We graph by pressing graph or zoom 6. We see the V crossing the x-axis or number line to the left of the origin, and we don't see the place it crosses on the right, but we see that it will cross and is close to it. We go to our table view by pressing second, then graph to see that table, and we scroll up to see the solution to the left. We verify that -5 is one solution because it's on the x-axis where y equals 0. We scroll down to see the solution on the right, and we see that 11 is that other solution. So here's our set of solutions. A equals -5 and 11. Now let's look at one last problem. Stop the video, solve for x, then restart it to see how you did. To be able to graph on a coordinate plane and use the x-axis as a number line, we need to solve one side for 0, which we can do by moving that 1 on the left to the right of the equal sign. On the right, the 1 becomes -1, on the left side is 0. Now we go to the function editor, or y equals view on the calculator. We enter the right side of the equation in y1. We now graph by pressing graph or zoom 6. We see the classic V shape of the absolute value function. Does it touch the x-axis anywhere? No, it does not cross the x-axis and therefore has no solution. Today we've looked at solving absolute value equations by graphing. Remember that in order to get the absolute value operation, we first press second, then 0 for catalog, then enter. This has been solving absolute value equations with the graphing calculator. I hope you've learned something today. Thanks for viewing.